Welcome to episode 481 of AI Brief. I'm Amin.
And I'm Leah, and we are your guides today.
We have an incredible agenda lined up for you today. We're exploring a fascinating new project that actually uses ocean waves to power floating data centers.
We also have a totally packed science update for you. That includes a computer that runs entirely without electricity and a Chinese EV battery that charges as fast as a quick coffee run.
And we will close out with a curated list of today's top trending AI tools to boost your personal productivity. But first, I want you to think about how we're currently seeing billions of dollars poured into making chips smaller and faster.
Which requires enormous amounts of power, every time you run a heavy application.
Exactly. Yet some of the most exciting breakthroughs we are covering today involve going in the exact opposite direction. We are completely rethinking how we generate power, discarding the need for electricity altogether.
The insatiable energy demand of AI computing is basically pushing tech out of traditional server farms and directly into the ocean. There is a Vancouver, Washington-based company called Panthalassa that is really pioneering this.
Wait, let me make sure I'm visualizing this correctly. Are we talking about putting delicate server racks on, floating barges out in the Pacific?
Well, they aren't just open barges. They are completely sealed, autonomous vessels. We are looking specifically at their Ocean 2 and Ocean 3 systems.
So how do they not just get destroyed by a storm or float away?
That is the genius of the engineering. They are self-propelled, meaning they can navigate to optimize their position in the water, they have no anchors, and there are absolutely no cables tethering them to the ocean floor.
So they are literally just freely roaming the ocean. How does the power generation actually work mechanically?
It relies on capturing the constant kinetic wave energy of the ocean. Imagine the up and down motion of the swells. These vessels use that movement to drive internal generators.
Converting the kinetic force directly into electricity on board.
Precisely. That electricity is then immediately fed into the servers housed securely inside the hull. They process complex AI computing tasks right there on the spot and then just beam the results back to shore via satellite.
And construction of the Ocean 3 systems is already underway, right?
Yeah.
With offshore deployment expected by August of this year.
Yes, it is moving incredibly fast.
It is conceptually like an offshore oil rig, but instead of drilling for fossil fuels to burn later, it is instantly turning the kinetic energy of the ocean into raw AI compute. If compute becomes entirely decentralized and mobile in the ocean, how does that fundamentally change the physical geography of the tech industry?
It completely erases the concept of a tech hub. This provides a scalable, sustainable alternative for AI companies looking to reduce their carbon footprint.
It fundamentally decouples AI growth from land-based power grid limitations.
Exactly. Think about what a data center requires. Massive tracts of land, proximity to power plants, and enormous amounts of fresh water for cooling. An autonomous wave-powered vessel eliminates all three of those dependencies. The ocean naturally provides limitless space and a cold environment to passively dissipate server heat.
I actually want to pause here for a second and take this next section a bit slower. The science updates we are unpacking next are incredibly dense.
You really are.
So we want to measure out these facts at a slightly slower rhythm so you can fully process the sheer scale of what is happening across these different scientific disciplines.
Because while Panthalassa is looking to the ocean to generate massive electricity, another group of scientists is asking if we need electricity to compute at all. We are looking at a novel computing system built entirely on the physical memory of springs and steel.
This is a profound shift from silicon back to pure mechanics. I am trying to wrap my head around how you get a physical piece of metal to process a 1 or a 0.
Think about a child's wind-up toy. You crank the key, and the internal spring physically stores that energy as tension.
Like a rubber band remembering how far it has been stretched.
Exactly. Now imagine that instead of releasing that energy to make a plastic toy move, the exact tension of that spring represents a specific piece of data.
So the physical deformation of the material is the data itself.
Yes. Through complex mechanical arrangements, these devices can count, they can distinguish different inputs, and they retain force measurements with zero electricity. They perform actual mathematical logic.
The utility here is incredible when you think about extreme environments. If you are operating heavy industrial equipment inside a furnace or deploying smarter prosthetics, traditional silicon hardware would just melt or get destroyed.
A mechanical computer completely bypasses all those electrical vulnerabilities. But to pivot from zero electricity tech, we also have an update on the absolute extreme of electrical charging speeds.
Right, the Chinese battery maker Sunwoda just unveiled the Xingqi Supercharged Battery 2.0.
It is an LSP pack, a lithium iron phosphate battery that charges from 5% to 95% in just 9 minutes.
That is literally the time it takes to grab a coffee. But achieving a 9-minute charge on an LFP pack usually creates massive resistance. The lithium ions pile up and overheat the system.
The secret to solving that is how they are using AI. They are embedding artificial intelligence throughout their entire battery design and maintenance pipeline.
So the AI maps out the chemical pathways inside the battery in real time.
Precisely. It optimizes the rapid chemical transitions to prevent that ion pileup, allowing the battery to absorb massive amounts of energy without degrading. They are also pushing into sodium-ion batteries for entry-level EVs using the same AI pipeline.
We shift our focus conceptually now from the energy of EV batteries to the ultimate energy forces in the universe. Scientists have achieved a world-first measurement of the real-time power and speed of jets blasting from a black hole.
Specifically, they targeted Cygnus X1, which holds the distinction of being the first black hole ever identified.
The staggering numbers derived from 18 years of continuous radio imaging are almost difficult to process. The jets pack the energy of 10,000 suns.
And they are traveling through space at 355 million miles per hour. That is roughly half the speed of light.
This is where I have a hard time visualizing the mechanics. When something is blasting through space at half the speed of light with the power of 10,000 suns, how does it actually sculpt a galaxy, as the scientists suggest? Wouldn't it simply destroy everything in its path?
It seems like it would, but those jets act as an immense cosmic engine. They aren't empty beams, they are superheated plasma. As they blast outward, they slam into the surrounding interstellar gas clouds,
Causing a massive kinetic impact.
Yes, and that collision creates physical shock waves that violently compress the cold gas. That extreme compression is the mechanical trigger required to ignite the formation of entirely new stars.
So it literally dictates the layout of the galaxy. That is incredible, but we need to transition from that massive galactic scale back down to the microscopic architecture of the brain. Northwestern University just achieved a breakthrough with artificial neurons.
These are flexible, low-cost artificial neurons that fire electrical signals. And the amazing part is that real brain cells in live mouse brain tissue actually respond to those signals.
Traditional electrodes used in brain interfaces are rigid, right? Which damages soft tissue over time.
Exactly. But these artificial neurons perfectly match the soft architecture of the brain itself.
If we connect this back to the broader picture of AI's energy demands, the implications are huge. Because these match the brain's incredible power efficiency, this biological approach could be a dramatically cheaper, less energy-hungry path forward for future AI hardware.
It perfectly addresses the exact energy crisis, forcing companies to put data centers out in the middle of the ocean.
Well, we just looked at the biological, brain-inspired hardware of the future. But let's shift gears and look at their software acting as your digital brain today. We have a rapid-fire overview of trending tools.
Let's start with Vantage in Google Labs. Say you have a tough, upcoming team meeting. You can use Vantage to generate an AI-simulated team to actually practice your delivery and assess your future-ready skills.
Then there is the new Gemini app for Mac. If you are drafting a complex email, you simply press Option plus space. Gemini instantly appears as a seamless overlay, pulling AI directly into your workflow without switching windows.
Next is Verdant 2.0. This acts as your AI technical co-founder. If you are launching a startup alone, you can use it to brainstorm system architecture or get advanced coding help.
Perplexity Personal Computer takes local integration even further. It provides an always-on voice control system that interacts directly with your local files and native apps, turning your computer into an active research assistant.
We also have Avena, which deploys go-to-market agents. You can automate the hunt and initial outreach for your next customer entirely in the background.
Finally, there is Fixit.dev. This is a cloud-native AI agent. You just give it a prompt, and it will literally build any web application from scratch. You don't write a single line of code.
It is wild how these tools change the workflow.
With tools like Verdant and Fixa effectively acting as co-founders and builders out of the box, what does the definition of a solo entrepreneur actually mean right now? You are basically managing a highly specialized digital workforce from day one.
We covered an immense spectrum today. We examined autonomous, wave-powered data centers floating in the Pacific Ocean and mechanical computers made of springs.
From cosmic jets to artificial neurons. If AI hardware eventually mimics the extreme efficiency of the human brain and our data centers become autonomous ocean vessels, the cloud of the future won't be in the sky at all. It will be organic, mechanical, and floating at sea. Follow the podcast on your favorite platform and share this episode with a friend who loves staying ahead of the curve.
See you in the next episode.
See you in the next episode.